Another leak code solution from DSCFIU. The problem that we have today is an part of the advanced problem set for the linked list section for our daily problems. The problem we have is merge two sorted lists. So we are given two linked lists which are sorted from least to greatest, and we want to merge the two lists together and return one list with the two numbers. So, for instance, we have example 1. We have 1, 2, 4, 1, 3, 4. So if we were to put one list together where it's sorted again, right, where the two lists are merged, we would get 1, 1, 2, 3, 4, 4. Or essentially, so we have two ones here. So also the elements don't have to be unique as well. So we have 1 and 1. We'll put 1 and 1 together, right? They'll connect it together. Then 2 from this list here will be added. Then 3 and then 4 and 4. And essentially that's what there is to it. So the numbers will go in from least to greatest. Pretty simple. So what is a way that we can approach this that might be able that will help us solve this problem? Well, what we can do, if thinking about it logically, if we want to merge two lists together, then what we can do essentially is have a few steps. We could do, let's see, the first thing that we can do is create a main linked list where the two lists will be concatenated together into one list. They'll be concatenated into this one list. So let's have a head node, right? A head node that will keep a track that these two numbers can go off of, and what we can do is we can keep pointers at each of these for each of these linked lists. So let's have start a pointer here, start a pointer here. Now, just like what we think, right? If we want to build up the list from least to greatest, then what we can do is we can go through each of these lists at the same time, and essentially we will be able to we could figure out whether which number between the two lists at a given point is smaller, and then add that to the list. So let's go ahead and do that here. Well, is one less than 1? Well, not necessarily, so it doesn't really matter in this sense. So we can have a condition whether if they're the same number, then the one on top will just be incremented. So let's go ahead and add the first one. Let's build that up. And now we're here. So we have is 2 less than 1? No, it's not. So we'll then connect. Now we're here. Is 2 less than 3? Yes, it is. So let's add 2, increment our pointer. Is 3 less than 4? Is 4 less than 3? No, it's not. So let's go ahead and let's add 3. Move it here. Is 4 less than 4? Or is 4 less than or equal to 4? Yes, it is. So yeah, and then you will reach outside to a null. Here, you don't have a variable that you can compare with to this 4. So you can do is whatever is in the other list, whatever there is left. Say there is this 4, right? But there could also maybe be like 5, 6, 7, 8, 9, 10. You just add all of those numbers to the end of the list. Since it is sorted, it will return you with the numbers that are greater than or equal to 4. So from there on, we can do 4 one more time. And this will be your answer. Oh God. I deserve a medal for that. So we have that head moving so in that direction. Okay, so what were the steps that we took to create this, right? And then we could return the head dot next. So we have this head, which allows for, we're building this up here. But also we will need a variable that points to this head. So let me do this with a different color. Let's call this P. Essentially, right? Because we're building up this linked list, right? Putting all of these links together, but every time we add to the linked list, essentially, right, we will be moving forward with the linked list, and we'll actually be going through the linked list as we build it. So we won't, well, if we try to just return this, we'll actually get a null variable because we'll be all the way over here, and that's not where we want to be, right? Well, that's not what we want to return. We want to return the stuff that's at the beginning. So therefore we want to have a pointer set from the very beginning that points to the head, and we could return head.next to get the proper linked list that we built here. So let's go ahead and write out this code really quick. So, and I'll put two screens side by side just so it's easy enough. We can go off of what we build here and build a solution. So I'm going to be coding in Java. You can code this solution up in any language that you like, but Java is the supreme language of choice. So we will be going with this. Perfect. So let's see here. So first thing we want to do is we want to build our head first. Or we're given a class of list nodes. We'll be using list nodes. Head equals new list node. We also want to build the pointer to the head so that we could return, right, the beginning of the linked list instead of returning the end. List node point equals head. So now let's go through the linked list, have iterate through each of the linked lists together and compare the values. So while 1 not equal to null and L2 not equal to null, we can go ahead and if the first value is less than or equal to L2 that val, then we'll increment the first. So head dot next equals L1. So we'll move forward with the linked list, right? Basically this is moving L1 to the next node, and head equals head dot next. So we'll be that's allowing for the linked list to keep building and keep moving forward. And essentially it's going to be the same, more or less the same logic for, well, I'll just write it out, but it would be pretty much the same. Otherwise, if the value at L2 is less than the value at L1, then we want to add the value at L2 to the linked list that we're building. So let's do head dot next. Bit of a mistake there. Equals L2 equals L2 dot next. Head equals head dot next. And from there, so we can go through that entire linked list. Right. So let's say we reach the end of one of the lists. If L1 equals null, then we want to just add everything that's on the second list to the first list. So L2. Else, we can just return. We can add whatever is left of L1. And you might be wondering, well, what if the lists are just sort of equal, right? What if there's nothing left to really, what if this was an identical linked list, right? What if this was 1, 2, 4, 1, 2, 4? We just kept adding them sort of together in some way. Well, since the next value is null, it doesn't really matter since, it's going to be the last, after 4, or this 4 here, is going to be null anyway. So if you were to add null to the end, then it's essentially the same thing as just leaving it null from the beginning. So that's just covering an extra test case. And yeah, from there, remember our pointer. So we want to return the head, right? But we can't directly because the head has been iterating, building the linked list. So the head is actually here. So therefore, if we want to get the beginning of the linked list, we need to return the pointer, but not the head pointer dot next. And let's just confirm in general. Point. Okay. That should be good. Let's submit. I assume it's fine. There we go. It runs perfectly. Yes. So what is now that we have solved the answer, what is the runtime for the solution? Well, the runtime should be O of n plus m, where n is the length of the first linked list and m is the length of the second linked list, because you're going through each of the lists, right? You're going through the two lists, and n and m depend on the sizes of those two lists. So therefore, that will be the runtime. It's just dependent on however long the list, those two lists are. And the space complexity should be O of 1 in essence, because you're just dealing with connecting pointers together. You're not saving all that space in memory. So yeah, thank you so much for listening. And if you like our videos, make sure to subscribe and like our videos. And make sure to join in on our Discord channel if you would like see more problems like these, and join in an awesome community of talented developers and to feel your passion in tech. Thank you so much, and I hope you have a great day.